Okay, good morning. This is August 25th, I believe. This is our first real day of math class, and I'm Mrs. Frandsen. Can you hear me okay in the other classrooms? Okay, so what I'm going to do first is I'm going to ask you to get your planners out, if you wouldn't mind. And I'm going to show you my agenda for this week, and you can write down what we're doing this week. If you haven't written down who has what math book as a teacher for me, that would be okay to do today too sometime. I'm not in a big hurry for those lists. Okay. So on Monday, yesterday, we did a multiplication chart. On Tuesday, today, we're going to have some discussion about prime and composite numbers. And then we'll get a worksheet called SR 4.3. Don't worry, it's super easy. If you happen to have some colored pencils, we will probably need to use those colored pencils. If you don't have colored pencils, don't worry, you can always color it in later. You can just use a regular pencil if you don't have colored pencils with you. Not until I'm done giving directions. Okay? Wednesday, we're going to talk about the divisibility rules, and the worksheet is called SR 4.2. And Thursday, we're going to talk about exponents, and the worksheet is 9 and 10. It'll be just one page, but the front is 9 and the back is 10. So I'll give everybody about 5 minutes and 27 seconds to go ahead and write that in their planner, and then have their math books on their desk, and their colored pencils, and their pencils. So if you need to take a moment to go get any of that stuff, you may go ahead and do that. Wait, one at a time though. One girl and one boy at a time. So Brody and Hayden. Did I get it right? Are you able to see in the other classrooms my agenda on your board clearly? This is fair. You would just go to my room. Yep. Okay, if we're out of our seat and just visiting with our buddies, that's a yellow slip behavior, so let's stay in our seat unless you need to get up and go do something. So you can't get your colored pencils? Will you go ask in the office to have a little market for you?
I don't know where the office is.
Remember where we watched the movies in the auditorium yesterday? Okay, it's just right across from that. Okay. Days, do you think it's been about 5 minutes and 27 seconds? Okay, if I could get some of the homeroom teachers to let me know how close your students are to being done writing down our agenda for the week, that'd be great. Because really, when I say I'm giving them 5 minutes and 27 seconds, I don't actually set a timer. I just make up a number.
Ellen's class is done. Your is done. Okay, we're done in this class.
Okay, what I'd like to try next is I'd like to try to turn one light off in my classroom to see if it makes it less reflection-y on the smartboard screen for you to be able to see better. Does that make it better to be able to see more clearly?
Yes.
Hey, that's how I'll leave it then while I talk. So on today, when we talk about prime and composite numbers, all you need to do is just kind of listen and wait, and in about, I don't know, 15 to 20 minutes, I will be giving out a handout that has a hundreds chart on it. So for those teachers in the other classrooms, if you have that hundreds chart ready somewhere, that would be great. If you've already handed out, that's fine too. Okay, but just know that is the one that we will be working on today. Okay. All right. Now I'm going to take myself off my screen, so until I see you next time, but if I happen to walk in front of my iPad, you'll see me again. Okay. I'm not sure what I just did. Okay, if you can see the front page of my PowerPoint presentation, it should say getting started, okay, and then your math book, prime and composite numbers. Hopefully everybody can see that. And then there's a bunch of little drawings around the outside edge of that. So what I'd like you to do is just have your math book on your desk in front of you, the hard one, not the soft cover one. That one you can put away today. We're not going to use that today. Okay. Ladies and gentlemen, our math books are brand new. We have a brand new textbook. You guys are lucky because those old textbooks we had were very well used. So much so that they were falling apart and they were very, very, very ugly. So you guys, I would like you to take very good care of these books. Don't drop them. Don't wash them in your washing machine and dryer. I've had that happen before. Try to not let these ones get all banged up, okay? So they're brand new and later we'll put book covers on them, just not today, okay? You must keep the book that's assigned to you. You must put a cover on your book, which we'll do together later, unless you've already put one of your covers on it, but we'll still put a paper cover under that fabric cover later. And just be careful with the book. I'll tell you a little story time. One time, my son, Nicholas, had a brand new reading book, and he put it in his backpack with his cold lunch. And when he left that day, he forgot that he hadn't eaten his yogurt, and he just left his yogurt in his backpack, right next to his brand new reading book. So, in the bus, it happened to pop open and get squished all over his new reading book. And then we had to buy a new reading book because the yogurt dried and all the pages were stuck together. So, just keep your mind aware of the fact that sometimes in your backpack, if there's other things that are liquid, you could end up having problems like that. So find page 1 in your book. You're going to notice it's not the first page. Just find the one that has the 1 in the bottom corner. You find it? Okay. So it's a few pages in. Awesome. Awesome. There's a whole bunch of Roman numerals before you hit that page 1. So on page 1, and on the start of every single chapter, there's a STEM video. And that video is basically to tell us what it is we're going to be doing. By the end of the chapter, that video will make sense. However, they want us to show you that video at the beginning to kind of get you thinking about the mathematics that we'll be learning in chapter 1, and so on and so forth. So it kind of puts the whole thing together before we even start, so that I can reference that and make it connect for you and help you connect it in your mind. So I'm going to show you a STEM video, and hopefully it doesn't sound awful on the other side for everybody else in the other classrooms. I'm thinking, since I'm recording from my iPad, that the video should sound okay on their end, but we'll try it and see. Okay, so leave that open to page 1, and you can see that it talks about a STEM video, doesn't it? Okay. And I just told you everything that's written on this screen. These videos will show us what we will be able to do with the math when we're doing this chapter. Sometimes you'll hear things you've not yet talked about in your previous math classes, and that's okay. We will get to those things. All right. So to get to that, if it doesn't work, teachers, we can watch it on our own and pause, but I'm just going to try it this way.
I'm so excited to make some piñatas for the fundraiser.
Oh, me too. So how do you think we should split up all of the fillings?
All right, I hate to be so stop and go like that, but how did that sound, and can you see it clearly in the other classroom?
The sound was good and we can hear it well in here.
You could hear it well?
Yes.
Awesome. How about seeing it? Is it?
Yep, we can see it.
Okay.
All is good if you listen.
All right, so I will go ahead and wait for Miss Allen.
Sorry, it's at the back of the room. We can hear it good.
Okay, I shouldn't interrupt for a while now, so I'll go ahead and get it started again.
Well, I think we should make them all exactly the same so that nobody feels bad if there's a difference.
Well, that makes sense, but all the fillings are different amounts, so how do we divide them up equally?
Well, we can use the common factors of the different quantities, and that will ensure that each piñata has the same amount of filling.
I see, so then the greatest common factor will tell us how many piñatas we can make.
Right.
All right, so I think we can split these up into equal piles.
Okay, let's give it a try.
All right, start with the tappies. Now we have 2 piles of 25 tappies each.
So 2 is a factor of 50. But we can also make these into 25 piles of 2 each.
Which means that 25 is also a factor of 50.
But we're missing the easiest one.
We are missing the easiest one because we can count to 50 by tens. 10, 20, 30, 40, and 50.
Yeah, so we can make 5 piles.
So 5 is a factor of 50.
But we can also divide each of these in half. 10 is a factor of 50 with 5 tappies in each pile.
1 and 50 are also factors because 1 is a factor of any number and so is the number itself.
This is a lot of information. I think we should make a chart to keep track of the factors as we go on.
Oh, thank you so much.
Okay. Total is 50. And we have 1. We did 2, 5, 10, 25, and 50.
Great. All right, so that's the first one. Do you want to move on to keychains now?
Yeah, let's do the keychains.
All right.
Keychains. I love these guys.
Excellent. So we have 12 keychains here, and we can split them off into 2 piles of 6.
And 6 is a factor of 12, so I can make 6 piles of 2 each. But we can also split this up into 4 piles of 3 each.
This will also mean that we can break this down into 3 piles with 4 keychains each. The factors of 12 for these keychains,
12 here.
thank you, are 1, 2, 3, 4, 6, and 12.
Awesome. Let's keep going. All right. All right, so we finished the mints.
All right, so
Let's see what the common factors are. So 1 is always a common factor. And it seems like 2 is another common factor.
and actually 2 is the greatest common factor. So that means that we can make 2 piñatas with equal filling.
Bummer. I wanted to make more than 2.
Oh,
Wait, hang on. I have an idea.
okay.
Take 2 of the taffies away. That would leave 48. And that'll change our first row of factors.
Oh, okay. So if we switch that down to 48. All right, so then let's see. Now instead we are using 48 taffies,
Right? So 1.
and the new factors would be 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Wow, that really did make a difference.
48 has a lot of factors.
Mm-hmm.
So let's see. It looks like we have a 4, 4, a 4, a 4, and a 4. 4 is a common factor and also the greatest common factor. So that means we can make 4 piñatas with equal amounts of filling.
And you know, it's kind of cheating, but we can reward ourselves for all of our hard work.
How?
We each get to have a taffy.
Oh, yeah.
Okay, so that was the video that puts everything together. Some of you might have recognized some words that you already know, like factors. Let's think of a couple more. Maybe greatest common factor. Even though they didn't say greatest common factor, what they really did was find the greatest common factor of all of those numbers in their chart. Okay, so all of this will be stuff that we're talking about throughout this first chapter. So I'm going to go ahead and move on to the next part here. I can't remember what my next slide says though, because I'm having some memory issues. Let's see what it says. Oh, there's some more of the words that we were going to talk about. Factors, primes, and composites. So if you didn't mind for just one moment to put everything down and do a little stand-up, sit-down to help me know what you know. Okay, so if you've heard of factors before, go ahead and stand up. If you just heard the word factors, good. Go ahead and sit down. Okay. Now, when I say the word prime, I don't mean Optimus Prime, like the Transformer. I mean in a mathematical sense. So if you've heard the word prime in mathematics, go ahead and stand up. Good. And then sit down. And if you've heard of the word composite, go ahead and stand up. Awesome. So most of my kids were standing for each of those words. And those are basic keywords that we'll be working on this chapter. So have a seat and feel good that we already know some of what we're going to be talking about this chapter. Okay, turn your page to page 2 now. Who is the old dude on page 2? Take a moment to read the caption underneath his picture, please. Just take a moment to read it in your head. Yes. Just this little part under his picture. Just read that small paragraph under his picture. We're going to read it in our heads. And if you haven't already handed out the worksheet for today, teachers, you could do that now. If you've already done that, great. Okay, so now you've read about this guy on page 2. I would like you to just take a peek at his birth date. All right. And then also look at the day that he died, because of course he isn't with us anymore. Poor guy's gone. Right? So, is he somebody that would have been alive during Mrs. Frandsen's lifetime?
No.
No. What about Mrs. Frandsen's grandparents?
No.
No. So do you suppose this is new math we're learning today? No, this is super old math, but it's super important today still, okay? So if your folks say, I don't understand that new math they're teaching you in middle school, you can say, hey, look at my math book. This guy was born in 276C, and he died in, where is that? 194 BC. So he was really old. This is actually old math, right? So if they say they don't understand it because it's new math, you just tell them different, okay? All right, so what we're going to do with this piece of paper that you have in front of you is just hang tight, because we're going to use our colored pencils, but we're going to use them in a very specific way. Some of you might be thinking, Mrs. Frandsen, are you bonkers? We know how to count to 100. Why in the heck would you give mature, debonair, 6th grade students a 100s chart? That's for 7-year-olds. But we're going to use this 100 charts to categorize prime and composite numbers up to 100. So it's really not just for little kids. 100s charts can be used in the middle school. Okay, what we're going to do with it is we're going to use it as a sieve. A sieve is like a colander that you put your spaghetti in and then the water would drain out, right? And that's what this guy, this old dude, Aristophanes, he is the first one to do this with the numbers 1 through 100 to separate the prime numbers from the composite numbers, okay? A sieve is a utensil for separating finer and coarser parts of pulverized, granulated substances from one another. When I was a kid, we didn't have iPads and devices. I spent a lot of my summer out in the garden playing in dirt, and I literally had 3 or 4 different types of sieves. I didn't call them that. I just didn't even know what they were called. But I'd put dirt in them, and I'd shake them, and then the finer parts would fall through, and the thicker, heavier parts would stay on the mesh. So what we're doing with the prime and composite numbers is we're putting all 100 numbers in the first 100 numbers of our system through our sieve of Eratosthenes, and then we'll know at the end which numbers are prime and which ones are composite. I do have one announcement to make, so teachers and students alike. When we handed back our lunch cards today, there were 2 students in my classroom missing a lunch card. That was Emma McPherson and Brody Van Horn. So before lunchtime, when you pass out your lunch cards, if you happen to have those, will you send a student up here with them? That would be great. Okay. Now, we know how to tell the difference between odds and even numbers, right? That's super easy. Again, that's 7-year-old stuff, isn't it? But now we're going to examine prime and composite numbers. So basically, we're doing the same thing, but we're doing it for different kinds of numbers. Here's where I would start a video for us, but I've got to do it in a different way than from my Google, so just a moment.
I've had several requests to show the workings of the sieve of Eratosthenes. So here goes. It's an ancient Greek method of finding prime numbers in an array or the hundreds chart. It was created by Eratosthenes, one of those Greek mathematicians from way back. We can use this to identify prime numbers up to 100. The following steps will help us find the prime numbers. Start by crossing out the number 1.
Okay, don't do it yet.
You know why we cross out the number 1?
Just watch. Don't cross anything out.
Any takers? Well, it's because a prime number is any number greater than 1 and only divisible by itself and 1. So 1 cannot be a prime number because it is not greater than 1. Okay, now let's put a circle around the number 2. It is a prime number because it is greater than 1 and is only divisible by itself and 1. 2 is also the only even prime number. Next, we'll cross out all multiples of 2. To find the multiples of 2, simply skip count by 2. For example, 2, 4, 6, 8, 10, and so on. Did you notice any patterns for the multiples of 2?
All right, so when we look at what he's doing, we're not following along with him. We're going to wait with our colored pencils until Mrs. Frandsen tells you to color your charts. So if you've already started doing what he's telling you to do, that's okay. Just go ahead and erase for now. Okay, I forgot to tell you that. I'm sorry. Because we're going to do it a little differently than he does after we're done, and we'll do it one step at a time. Do you guys see the pattern for 2s on our hundreds chart? Yep, it's every column with a 2, a 4, a 6, an 8, or a 0 in the ones place, right? So there is a definite pattern for the multiples of 2. And we didn't cross out 2 because 2 is the only even number that is prime. In other words, it can't be divided by anything but 2 without getting a remainder.
You do realize I can't hear you. They all end in 2, 4, 6, 8, or 0. So if a number ends in 2, 4, 6, 8, or 0, then one of its factors is 2. Next, let's put a circle around 3. It's a prime number because it is greater than 1 and is only divisible by itself and 1. Next, we'll want to cross out all the multiples of 3. To find the multiples of 3, you can skip count by 3. For example, 3, 6, 9, 12, 15, and so on. You'll notice 4 is already crossed out. That's because it's already a multiple of the prime number 2. The next unmarked number is 5. I'll just place a circle around 5 because it is a prime number. Next, let's skip count by 5s. Do you notice any patterns in the multiples of 5? I sure hope someone got that. They all end in 5 or 0. So if a number ends in 5 or 0, you know one of its factors is 5. 6 is not a prime number. Do you know why?
It could be divided by 2 and
Because
3.
6 has more than 2 factors. Its
With no
factors are
remainders.
1, 6, 2, and 3. All the multiples of 6 are already crossed out, because if a number is a multiple of 6, it already had factors of 2 and 3. Looking at the table, our next unmarked number is 7. It is prime because it is greater than 1 and only has 1 and itself as factors. We'll circle it and then proceed to mark its multiples. Most of 7's multiples are already crossed out because those multiples have more than 2 factors. 8 is not a prime number. Do you know why? Because 8 has more than 2 factors. The factors of 8 are 1, 8, 4, and 2. 8's multiples are already crossed out because if a number is a multiple of 8, it also has a factor of 2. 9 is not a prime number because its factors are 1, 9, and 3. It has more than 2 factors. All the multiples of 9 have also been crossed out because they have other factors besides 9. For example, 18 is already crossed out because it has factors of 1, 2, 3, 6, 9, and 18. 10 is not a prime number because it has factors of 1, 2, 5, and 10. All the multiples of 2 and 5 have already been crossed out. This also means that all of the multiples of 10 have been crossed out. Now that we found all the multiples of 2 through 10, all we have left that are not circled are prime numbers. Why are they prime numbers? Remember, because they only have factors of 1 in themselves. Our prime numbers between 2 and 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So remember, in order to find a number that is not prime, try to see if it is a multiple of another number. And as always, the sieve of Eratosthenes is your safety net for prime numbers. Uh-oh. I need a vacation.
So that is our video about prime numbers. And then we'll go back to my getting to know you PowerPoint here. So what I'm trying to tell you is basically any number that cannot be divided by itself or another one evenly is going to be a prime number. Basically, we separate these based on the number of factor pairs that make the number. If there's more than one factor pair, other than 1 times itself, to be able to build that number through multiplication, we call it composite, right? Prime is when it's only 1 times itself. And I think that the first time people noticed prime numbers was when the cavemen, even before Eratosthenes, a lot of people think this too, that the cavemen would count the number of days between a full moon, okay? And they'd come up with 29. Well, when they tried to make a calendar with equal number of days between those moon cycles, they were unable to do so because is 29 prime or composite? Well, 1 times 29 builds 29, but can 2 times something equal 29 without a remainder or a decimal? No. So if you remember on the sieve of Eratosthenes, that was one of our prime numbers. So that was the first time they realized, I think humans realized, that there were such thing as prime numbers, numbers that can only divide by themselves or by 1 without remainders. Okay, so is that new math? That's even older math than the sieve of Eratosthenes. So indeed, and that's a theory. We don't know for sure. We weren't there when the cavemen were there, and they weren't writing books back then, so we don't know for sure, but that's my theory. All right, so Mustache Guy showed us how to identify all the composite numbers. Here's what we will do. We will color in all the composite numbers on our hundreds chart. Then the blank ones are the prime numbers, okay? So if you have your colored pencils out, you may go ahead and pick any color you want to lightly color every number that ends with a 2, 4, 6, 8, or 0, except for the 2. The 2 is the only prime number that's even. So don't color that in because he's prime. I'll give you a minute to do that. If you don't have colors, it's okay. You can lightly cross out the numbers that you need to color later. Just lightly put a cross on them with your regular pencil. Yep. Just go all the way down that row. So literally what you guys are doing right now is old math. You're separating out the prime numbers from the composite numbers. The sieve of Aristophanes is what we're recreating on your piece of paper here. You should be more than halfway done coloring all of those by now. So if you're not, you might want to color Tish faster. As I look around my room, I see most of my kids are done coloring all of the even numbers except for 2. So I'm going to show you the next one on my PowerPoint. Notice how I have some purple numbers highlighted now because the next number is 3. So all the multiples of 3 need to be filled in. Now some of them are already filled in, so you don't have to worry about them because you colored them in, but some of them aren't, like 9, 15, 21, 27, and so on. Go ahead and fill in those numbers as well. All the multiples of 3 from 1 to 100 should then be colored in. You know what I got to thinking? If you didn't bring colored pencils, I actually do have some. Do you want one?
No.
I feel bad. I forgot about that. I have extra colored pencils. So I wasn't even thinking, I do have a box here of extra colored pencils, so is there someone else who wants a colored pencil? Okay. I'm going to move on to the next chart, but don't worry because I'm just building upon the previous one. So if you're not all the way done filling in for the multiples of 3, don't worry about it because they'll still be there, but I'll talk about the next set of multiples. The next set of multiples are all the 5s. So every multiple of 5 needs to be highlighted. We have a lot of them already done. because remember, 10 is an even number, and any number ending with 0 is also an even number. So all we have to do for the multiples of 5 are fill in under 15, 15 all the way to 95. God bless you. Okay, the next multiple we're going to talk about is 7. The multiples of 7 are highlighted in yellow on my chart. Did I miss any? I hope not. All I really did was I started at 7 and I started counting by 7. 1, 2, 3, 4, 5, 6, 7. Oh, it's already filled in. 1, 2, 3, 4, 5, 6, 7. Oh, it was already a multiple of 3. 1, 2, 3, 4, 5, 6, 7. That was also a multiple of 3. So as I went through, I just made sure the ones that weren't multiples of any other numbers, like 49 is built by 7 times 7. So I knew I had to get 49 colored. 7 times 11, 77. And then 7 times 13 is 91. So there's really only 3 numbers to color in for that one. Okay. So the next thing I have on my PowerPoint is that we're going to work in the journal, and I forgot that I put it there, but yeah, because on the back side of your paper, you actually have some prime and composite practice. I don't think you need to open your journal and do the prime and composite practice on that page unless you really want to. Okay, the journal is under your desk still, and you could do that maybe during study hall time if you want more practice on differentiating between prime and composite numbers. So once we have this part of our paper filled out and colored in, we should be able to easily answer the questions on the back side of the paper. Okay? If you want more practice, you can do the review and refresh for chapter 1 about prime and composite numbers. All right, Factor Samurai. Factor Samurai is a great game. I have it on my math iPads. About 7 years ago, I got a grant from OneOak for $5,000, which was able to get me 10 iPads for my math classroom. And on those iPads, I have bunches and bunches of math games. Factor Samurai is a super fun game to help you recognize and identify the difference between prime and composite numbers. I'm going to show you a short video that tells you a little bit more about it. I think that this is only on Apple devices, but it might also be on Android devices. It's just that I don't have any Android devices to try it on. It is almost like Fruit Ninja. Yes, Nellie.
All right, so this is Factor Samurai. I absolutely love this game. I'm going to show you how it works, okay? I'm going to hit play now. And depending on how comfortable you are with divisibility and factors and all that sort of stuff, you can choose your level of difficulty. I recommend starting with Grasshopper, but I happen to know that I'm at a master level, but I'll show you Apprentice. Now, what we want to do is we want to slice through numbers that we can divide as the screen moves. Now, if you swipe up, it'll actually propel those factors that it splits into a little higher on the screen so you have more time to slice through them. But you want to avoid numbers that, oh, I missed one. You want to avoid numbers that are prime Whether you realize this or not, you're going to figure it out as you go along. Oh, and there's a gold, it's a gold sword. So if you see the swords, hit them too. But you're going to go as far and as long as you can on this. And it's okay. Eventually, everybody sort of ends up messing up. And I've already made a couple mistakes here. But that's as simple as it is. And it's different every time you play. It'll be a little bit different. And as you play, you'll get better and better at recognizing what numbers you can split and which ones you can't. And eventually, when you make enough errors, and here I'll purposefully, there we go, it'll tell you, hey, nice job, how you did. Now, what you're going to be learning as you play this game are which numbers can you divide into smaller groups and which numbers then can be split into prime factors. You'll catch on quick, I promise.
Okay, so what you're going to find out then is I'm going to show you throughout the school year different games that you can get for your devices that you can practice math concepts in. So those of you who have iPads, or even if you don't have an iPad, maybe you can do it on Android. Write down Factor Samurai somewhere on your paper. So later today when you're at home, you can say, no, Mom, I don't have any math homework, but I could play a math game if you let me download it on the iPad or on your iPhone or whatever. A lot of us don't even have phones yet. We're not 13, right? So, or 16. Some of us have to wait till you're 16.
Yeah.
Jiminy Crickets, not the ancient.
So.
You are so deprived. I feel so bad for you. Okay, so then the other thing I want to tell you is when you're in my homeroom class during the study hall, if you're all caught up and I'm feeling in a super great mood because you guys haven't been doing too much extra chit-chatting, right, or being naughty, I can give you guys a chance to use your actual device to play games like that, or to even borrow one of my devices to play games like that. So it is up to the other teachers whether or not they let you do those types of games on your actual own devices. But just know, when you get to my room, there'll be days when you get extra practice on those math games that I'll be showing you throughout the year. And that's really all I have for you guys today. And if you have any questions on how to complete the back of your paper, say you read the marching band one and you're not quite sure what to do, don't stress out. This first assignment is not graded, and tomorrow we're going to go through those questions together. Okay, so don't stay up until 1 o'clock in the morning trying to figure out number 20. Just know you'll need to pay attention tomorrow when we talk about that one, okay? Is that a deal? Because I don't want anybody to be stressed about math. Math is supposed to be fun, okay? I'm going to hang up now from the group meeting and just let them work on the back side of their paper, and if they want to, they can work in their student journal on that extra practice page too. Okay, it was nice to see you guys. So Brody, you had your hand up.
So you don't do this stuff right now? Like 5 through 21?
Yeah, you can do 5 through 21 on here, but you don't have to if you don't want to get your student journal out to do that. I wasn't originally planning on giving this on the back side. Oh, that is just too bright. Sorry, guys, that was bad.
I didn't mind it.
You don't mind it? Okay. So on the front side, you've already filled all the colors in, and on the back side, this you want to have done by tomorrow, okay? But like I said, if you don't get all of them done because you're confused on any of them, just relax and know tomorrow I'll explain how to answer those questions. Okay? Yes.
I can tell different not long ago, and they were placed on water.
Well, it wasn't built when Eric Sospenade was alive.
That's not that old.
Yeah. Yeah, just leave your planner on my desk. Okay, I'm gonna go back to this screen that shows all of the numbers colored in, so you can double check if you feel like you need to. Can you guys see them all?